Now we are going to explain the first lesson in the second unit. Lesson 1, it is talking about the properties of sound. Properties of sound, we are going to study 3 of them. 3 properties of the sound. The first property, first we have to know what the meaning of sound. Sound, it is an external factor, external stimulus or factor that affects the ear, causing the sense of hearing. That's meaning the sound is the sense of hearing. Because of it, we can hear the sound around us, from its source to our ear. Again, it is an external stimulus or factor that affects the ear, that causes the sense of hearing. Before we talk in the first unit, the sound belongs to which waves? The sound belongs to which waves? Sound belongs, number 1, to the mechanical wave. Number 2, to the transverse waves. You collect the 2 words together, so we can say sound is mechanical longitudinal waves. The sound is a mechanical longitudinal waves. Of course, mechanical has a meaning. Longitudinal waves has another meaning. Mechanical is meaning that it needs a medium to propagate. There is a medium, the sound can travel. There is no medium, the sound cannot travel. This is the meaning of mechanical, and don't forget that in the mechanical, it will be 2 different kinds of waves. One of them is the transverse waves. The other one was the longitudinal waves. Sound belongs to the longitudinal waves. I mean the second type of the mechanical. Longitudinal waves is meaning what? Is meaning that the sound particles of the medium vibrate along the wave propagation direction. So we have to know and differentiate between the meaning of mechanical and the meaning of longitudinal. Again, mechanical has a medium to propagate. Longitudinal means the particles of the medium vibrate in the same direction of wave propagation. Like what? Like if we have this is a particle of the medium. If the particles of the medium vibrate up and down, if the particles of the medium vibrate up and down, and the wave propagates horizontally, that's meaning both of them will make a right angle. If the particles of the medium vibrate perpendicular on wave propagation direction. This is not longitudinal waves. This is the transverse. Transverse wave. But if we have, this is the particle of the medium, vibrate right and left, and the wave propagates horizontally, that's meaning they have the same direction. This is a long. This is the second type. This is what I'm talking about, the sound. This one is talking about the sound. So in the description of the sound, particles of the medium vibrate along or in the same direction of wave propagation. This arrow is meaning the wave propagation direction. But this one, 2 arrows right and left, is meaning the vibration of the medium particles. Vibration of the medium particles must be in the same direction of wave propagation. This is the meaning of the mechanical and longitudinal waves. First, we have to say that when the sound can be produced. Sound can be produced only if the body is vibrated. If there is a vibration like this, there is a vibration, there is a sound. If there is no vibration, there is no sound. We said before that the sound needs a medium to propagate. So its velocity around 340 meters per second if the sound is traveling through the air. Through the air will be different from it's transferring through liquid. It's transferring through the solid from one to the other. And this shows if we have a different body are making the vibration. This is a tuning fork. When the tuning fork produces sound, it vibrates, and then the particles of the air around it will vibrate also, and this is the only way of propagation for the sound waves. But actually, if the sound is produced, it will produce group of waves. These waves will take in the form of circles away from the source of the sound. Away from the source of the sound. So, if there is one standing here, can hear the sound. If there is another one standing here, can hear the sound also. If there is another one standing here, can hear the sound also. That's meaning we can hear the sound from all directions. Because, number one, sound travel in the form of spherical waves. It's center in the source of the sound. Number two, it is a series of compression and rarefaction. And this is the structure of the sound waves. And then, if there is a problem taking about the calculation of the wave velocity for the sound, the wave velocity of the sound generally equal the same rule to be calculated by the wavelength and the frequency. We have three factors in the rule. One of them is the wavelength, measuring unit by the meter, wave velocity, measuring unit by meter per second square, but the frequency, its measuring unit is the hertz. Then, any one of them, we can produce the sound from it. Sound heard by the human ear can be classified into two different categories, two different types: musical tone and noises. They are different from each other according to the frequency, according to what the effect on the ear, and according to its source. If we are talking about the musical tone, it has a uniform frequency, and if we are talking about the uniform frequency, that's meaning we will have this is a uniform frequency. That's meaning the shape of the crest repeated, similar, the shape of the trough repeated, similar also. But if I'm talking about a frequency like this is a non-uniform frequency. So there is a big difference between the uniform and the non-uniform to differentiate between the musical tone and the noise. The second one is the effect on the ear. If you are hearing the musical tones, my ear is comfortable. Comfortable is meaning a gut feeling and hasn't a bad effect on the ear. But in the case of the noise, like the drilling, like the horns of the car, this is uncomfortable for the human ear. For example, any kind of musical instrument, one of them is the violin, the other one for the noise is the drill. Drill, this is the tool that making the sound to make a hole in the ground. We can describe the sound by using three different properties. Sound actually has its own special description. If you want to describe it, you have to describe it by using the sound pitch, you have to describe it by using its sound intensity and the sound quality or the time of the sound. First, what is the meaning of sound pitch. If we want to differentiate between when the woman produces a sound and when the man produces a sound, we will notice that the woman sound is sharp, while the man's voice is harsh or rough. This is the one property of the ear that can differentiate or distinguish between the sharp sound and the harsh sound. Sharp sound, if the sound which is produced is sharp, I can say this sound has a high pitch. High pitch produces sharp sound like the woman's voice, while the harsh pitch produces a rough sound such as the man's voice. This is the meaning of the sound pitch. I will say it again. It is the property of the sound that the human ear can distinguish. To distinguish is meaning that can differentiate between the harsh sound and the sharp sound. Actually, if the sound is harsh or even sharp, this mainly depends on the frequency. The frequency of the sound waves. So, if the sound is sharp, that's meaning there is an increasing of the frequency. Number one, the sharp sound related to the high frequency, related to the high pitch. High pitch for the high frequency, for the sharp sound. But what about the other type, which is the harsh sound? Harsh sound is meaning its frequency is low. So we can conclude that there is only one property for the sound, depends on it to describe the sound pitch, which is the frequency. And the frequency, we talked before, it is the number of complete oscillation made by the oscillating body in 1 second. I mean number of waves and time. So, woman voice has a sharp or soft with a high pitch with a high frequency. Man voice, rough or harsh, low pitch, low frequency. This is the comparison between the rough and sharp sound. In this case, we have two pencils fixed by using stretched string, and we are going to change the length of this string. And while pulling it, we will hear the sound and compare between them if it is a harsh sound or a rough sound. I found that if you are going to increase the length between the two pencils, this is well, by pulling it, of course, it will produce the sharp sound. Increasing the length of the rubber band covering the two pencils will produce a sharp sound. While if this length became smaller, it will give another kind of frequency, another kind of sound pitch. The sharp will be rough. That's meaning the sound pitch increases by increasing the frequency, decreasing by decreasing the frequency. And if we are going to compare between them by using the drawing, this drawing explains exactly a number of complete waves lower than this number of complete waves. That's meaning this wave has a higher frequency due to increasing the number of waves, but this one has a lower frequency due to decreasing the number of waves or the number of complete oscillation. So if there is a sound produced from this wave, as the sound waves will be harsh or rough, but the sound will be produced from this one will be a higher pitch and has a higher frequency. Okay? Like this exactly, we have different bottles or different cans that which is containing a liquid inside it, and here the difference between the different drawing and the column of air inside them. Can you guess which one will give you sharp? Which one will give you sharp one? Everyone don't know? We have here a column of the air longer than the other ones. That's meaning the shorter the column, shorter the column of the air gives a high pitched, a sharp one. That's meaning the sound which is produced from this one will be rough or sharp will be rough. But the sound which is produced from here due to the decreasing the length of the air column inside it will be a sharp sound. Right? The last thing, who can prove that? Can prove that? One called Savart, he made a wheel, this called Savart's wheel. Savart's wheel will prove that the sound pitch depends on the frequency. The sound pitch will be changed according to the changing of the frequency. This Savart's wheel is, the point is, I have a different number of gears. These gears have a different number of teeth. يعني the number of teeth in this gear will be different to the number of gears in the other one. I will, or I can calculate what is the value of that frequency by knowing how many cycles we can control the cycles, and you can put iron plate or a hard plate on the teeth of the gear and then rotate it. You will hear the sound. You will notice that if the gear has a larger number of teeth, you will hear a sharper sound. If you increase the number of rotation, you will hear a sharper sound. That's meaning here in the Savart's wheel, two factors controlling if the sound is sharp or rough. Number one, number of teeth. Number two, the number of rotation or the number of cycles. So that all the examples, frequency equal the number of cycles times the number of gears teeth over the time per second. And this is the only work for the explanation, the first property of the sound waves. In the next session, inshallah, we will continue what are the rest properties of the sound waves. Thank you.